Hello again, welcome to my Calculus Conundrums applications of derivatives, and we're still talking about extrema here, but what I'm going to show you here is the first derivative test. Be sure and subscribe if you like what you see. Now there's going to be two tests that we use to find extrema. One's called the first derivative test and the other one's called the second derivative test, but we won't get to that until after we talk about concavity. So right now, the first derivative test, you can read this first paragraph, but basically let me just get to it. As long as the function is continuous and c is a critical number, okay, so let's say that you know that c is some critical number, and then if the derivative of the function is negative to the left of the critical number and positive to the right of the critical number, then f of c would be a relative minimum. So if you take a look down here, you'll see that here is a critical number at 3. Just trust me, it's 3. Alright, so the critical number at 3. And notice that to the left of 3 the function is decreasing, which means the derivative is negative, and to the right of 3 notice that the derivative is positive because the function is increasing. So based on the first derivative test, we know that f of 3 is a relative minimum. Now here it says if f prime is positive to the left of c and negative to the right of c, then f of c is a relative max. Now, take a look here. Again, at 3, you got a critical number here because you got that sharp corner. So x equals 3 is a critical number, and notice to the left of 3, the function is increasing, which means the derivative is positive, and to the right of 3, the function is decreasing, which means the derivative is negative. So since the derivative is positive to the left of 3 and negative to the right of 3, then f of 3 is a relative max. Now the next one says, basically it says if it doesn't change sign, you don't get a minimum or a maximum at x equals c. So if the derivative is negative on both sides of x equals c or positive on both sides of x equals c, then f of c is neither a relative min or a relative max. So I'll show you examples of that. Here you've got a critical number at 3 because at 3 you get a vertical tangent line here. So notice to the left the function is decreasing, so the derivative is negative, but to the right of 3 the function continues to decrease, so it's also negative to the right of 3. So to the left of 3 the derivative is positive. Excuse me, did I say negative? Well, I'm sorry, I should have said negative. It is negative, but I'd have it written wrong here, so let me correct that. Okay, just a typo. So here the derivative is negative to the left of 3 and the derivative is negative to the right of 3. So the derivative is less than 0 to the left of 3, the derivative is less than 0 to the right of 3. So therefore f of 3 is not an extrema. And then here the function is increasing here, so the derivative is positive to the left of 3 and it's still increasing over here, and the derivative is positive to the right of 3. So therefore f of 3 is not an extrema there either. So basically that's how you apply this test, and we'll apply the test in a very similar fashion that we applied the increasing decreasing test earlier. So to apply the test, we're going to get the derivative and then determine the critical numbers. So I got the derivative of this, and then I factored 9x out, and I found that the critical numbers are 0 and 4. So now I'm just going to break it again. Here you can see I'm going to break it at 2 places. I'm going to break it at 0, so I break it there at 0, and then I break it there at 4. And now notice when I plug a number in to the left of 0, plug -1 in to the derivative, and I get a negative value. I get a positive value. I lied, positive value, because I get a negative times a negative. So I get a positive value for the derivative. And then when I plug a number to the right of 0 in, like 1, I get a positive times a negative, so I get a negative value. Well, since it's negative to the right of 0 and positive to the left of 0, based on the first derivative test, we must get a relative maximum. So the derivative is positive to the left of 0, negative to the right of 0. So the function has a relative maximum of whatever f of 0 is. And it turns out f of 0 is just 0. Of course, you can get that by just plugging 0 into the function. All right. Now, what about at 4? Well, at 4, remember, to the left of 4, the derivative was negative. So let's pick a number to the right of 4 and plug it in. So if I plug 5 in, I get a positive times a positive. So the function is, the derivative is positive to the right of 4. So therefore, to the left of 4, the derivative is negative. To the right of 4, the derivative is positive. So based on that, then we get a relative minimum of whatever f of 4 is. And it turns out if you plug 4 into the function, you'll get negative 96. Okay, now if you want to look at the graph, you can see that at 0, now looking at the graph is cheating, so just be careful. But if you look at the graph, you'll see that at x equals 0, you get a relative maximum value of 0. And at x equals 4, you get a relative minimum value of negative 96, just like I said. Okay, now you can pause the video and do this one, but just do it just like the one I just did, because this is just another polynomial. And so it's very similar to the first one. So I'm not going to do this one. I'll let you do this one as a practice problem. So pause the video and then work it, and then you can see if you get the same thing that I got. Now the next one is a rational function. So on this one, remember we found the derivative of this earlier. It's minus the quantity x minus 1 times x plus 1 over x squared plus 1 quantity squared. And the critical numbers to this are 1 and negative 1. So I drew my number line, I broke it at negative 1 and 1, and those are the three intervals I would have. And then I plug in negative 2 from this interval, and when I plug negative 2 into this, well, you're actually going to get negative times a negative, which is positive, and then times a negative here. So the numerator is going to be negative, and then the denominator is always positive because it's squared. So you're going to get a negative over positive, which is negative. So the derivative is negative there. And then here, the derivative is, let's see, if I evaluate this at 0, plug 0 in, I'm going to get a negative times a positive, which is negative. And let's see, and a negative times a negative is positive. And so I get a positive on top, positive on bottom. So the derivative is positive there. And then here, when I plug 2 in, I got a positive times a negative right there. So the top is negative, the bottom is positive, so I get a negative. Now I didn't mean to leave this in here because I'm not worried about, we're not studying increasing, decreasing. We're doing the first derivative test. But it's okay if you put that. But here, right here, we've got to the left of negative 1, the derivative is negative. To the right of negative 1, the derivative is positive. So that means we get a relative minimum of f of negative 1. And it turns out if you plug negative 1 back into this function, you get negative 1/2. So we get a minimum f of negative 1, which is negative 1/2 at x equals 0. And then at positive 1, did I say x equals 0? That should say x equals negative 1, not 0. Probably just a copy and paste error. All right, and then at x equals 1, to the left of 1, the derivative was positive. To the right of 1, the derivative was negative. And so we get, so therefore, by the first derivative test, we know we get a relative maximum. Boy, I got this messed up, don't I? So we get a relative maximum. So let me correct that. Okay, I corrected it. So we actually got a relative maximum of f of 1, which turns out to be 1/2 at x equals 1. Okay, so there, I think I just copied and pasted these lines from a previous problem, and I didn't change the values. So anyway, so as I said, you can see from the graph here, at negative 1, you get a minimum here of negative 1/2, and at positive 1, you get a maximum of positive 1/2. Okay, now remember this function's, its domain is negative 1 to infinity. And earlier we found the critical numbers were negative 2/3 and negative 1. And so when we did this problem, we know that right here it starts at -1 and then goes to infinity, and then right here is -2/3 where we broke it at. So really, let's just look to the left of -2/3 and notice the derivative is negative, and let's look to the right of -2/3, and if you plug a number into the right of -2/3, you'll see that the derivative is positive. So since the derivative is negative to the left and positive to the right, then we get a relative minimum of f of -2/3, and I went ahead and calculated this as -2 square root of 3 over 9. So that's our value. Now the decimal value you can see down here is actually like -0.385, but it's this point right here. So this point right here is our minimum value, so we get a relative minimum there, and that was the only extrema we had. Technically this could be considered a relative maximum here at -1, 0, because it is the highest point in this region. Okay, I'll do one more on here, and then I've got a couple of trig functions I'll do on the next video for this section. So here I have x squared minus 4 to the 2/3. Here's the derivative. So earlier we found the critical numbers were x equals 0, because that makes the derivative 0, and -2 or +2 makes the derivative undefined. And these values are in the domain of this function. So now, just break it here at, so break the number line here at -2, break it here at 0, break it here at 2, and then that gives you those 4 intervals. And then to the left of -2, we'll plug -3 into the derivative, and when we plug -3 in, we'll actually get that the derivative is negative. And when we plug -1 in, that's a number to the right of -2, we get that the derivative is going to actually be a positive value. And then when we plug a number to the right of 0 in, we get that the derivative is actually negative. And then when we plug a number to the other side of 2 in, like 3, we get that the derivative is positive. So let's take these one at a time. So at -2, the derivative is negative to the left of -2, and the derivative is positive to the right of -2. So that must mean we get a relative minimum at -2. And then at 0, the derivative is positive to the left of 0 and negative to the right of 0. So that means at 0 we get a relative maximum. And then at 2, the derivative is negative to the left of 2 and positive to the right of 2. So again, we get a relative minimum again for that. So the point -2, 0 and the point 2, 0 are relative minimums. So really the y value is the minimum, 0. So you can see in the picture here, you've got a minimum of 0 here, you've got a minimum of 0 here, and then here I got 2 cube root of 2 by plugging 0 into this and simplifying it. Now 2 cube root of 2 is the exact answer, and on the graph I used the approximation answer, 2.52, for the relative maximum. Okay, and so that's all I'm going to cover on this video. I am going to continue this process on the next video with a couple of trig graphs. So if you don't need to cover trigonometry, then you can skip the next video, but if you're in a Calculus 1 course, you better go ahead and watch it.